Okay, I'm going to do this question with you, going through a decision table and then simplifying it. Then what I'd like you to do is try the mock question again and see if you can actually do it correctly based on these sort of techniques. So to begin with, we've got our conditions and we've got our actions. Every decision table is split between conditions and actions. So we've got 3 different tests. One test is to check all the dimensions are correct. One test is to check strength. And one to check the paint color in this assembly line. So at the end of the assembly process, each product item is comprehensively tested to decide whether the item is accepted or not. Only if all 3 items, so if all 3 items are accepted. So if the item passes all 3 group tests, so if 3 is yes, so if all 3 are yes, then accept. If the group 1 tests are passed, but exactly one of the other 2 group tests fails, it's going to send to repair. So elif, if we're doing this as programming, 1 is y. So the first one, so I'm going to 1 to 3 here. But, so, and 2 and 3 are no's, we go to repair. Else, reject. Sorry about how slow this is. I'm going to get a pen for this very soon. Okay, so this is going to be quite simple to fill out. So we said that if, where's my mouse gone, man? There we go. Hello, mouse. If that's a y, that's a y, and that's a y, it's going to be accepted. If that's a y, and we'll do that's a y, but that's not a y, we're going to say, oh my gosh, we're going to go to repair. Otherwise, if that's a y, that's a no, that's a y, repair. Otherwise, if that's a y, that's a no, and that's a no, it's going to be rejected. Otherwise, if this is no, and this is a yes, and this is a yes, it's going to be rejected. If this is a no, this is a yes, and this is a no, rejected. This is a no, this is a no, this is a yes, rejected. This is a no, this is a no, and this is a no, rejected. Okay, so the next thing we're going to have to do is remove redundancies. Now, the rule when we talk about, or the step to take when we talk about redundancies is, any 2 rules which have identical entries except for one condition rule. So, if we look at all of these, this in itself, the first column, is unique because we've only got one action, yes, for this. So I'm going to put it in as our definite. Okay, so the next thing we're going to do is take into account our second test, where we're looking at yes, yes, no. So I'm going to put yes, yes, no, and it's going to go into repair. Theoretically, if I did this could actually be these two, theoretically, could be made redundant, but the difference is that what we need in this question is at least two y's in order for an n. So if I did y, n, y, perfect. Another one which is going to be different is going to be this one. What happens if you had y, n, n? And then what happens if we have, now this is where we can make some redundancies. You notice that these all start with n. Therefore, it's pointless copying all of these out. The outcome is always going to be y. So I'm going to do n here and dash dash, which basically means any combination repeated. And there we have this. This has been, well, we've used redundancy to simplify this. I'm going to give you another one on the next video.